Okay, students, so I'm going to show you how to do a t-test in Google Sheets. So the first thing that I'm going to do is I'm going to get onto my computer, pull up Google Sheets, and I'm going to rename my document, hopefully. And I'm going to name this Student Tutorial. So you probably had some number of trials. And we'll say, for the sake of argument, that this group did 5 trials, and they were counting the dyspnea heartbeat, and they added caffeine to one group. We'll call this caffeinated. And the other group, they did not add caffeine, so we'll call this decaf. And in the first group, let's say that the first heart rate count they got was 135 beats per minute. So I'm going to have to put my units in here, right? I'm not sure if you did beats per minute or beats per 10 seconds, but we'll do beats per minute. And in this group, we're going to go ahead and do, let's say it was 150. We got better at counting the heart rate. The next one was 165. The next one was 170. And the next one was 160. All right? And then in the decaffeinated group, or the control group, we also took 5 different dyspnea, and we got some different data. So our first one was 125 beats per minute. Once again, we got a little bit better, and we ended up with some data fluctuating around 130 beats per minute. That's actually pretty low for dyspnea, but and I'll do this one a little bit high. Okay. So one of the first things that I want to show you how to do is how to calculate your average. So I'm going to write in average here. So let's figure out how we're going to do the average. The thing is that when you're doing a formula, it's really important that you use capital letters. So we're going to go to the box underneath our data, and we're going to hit the equal button, the equal sign, and then I'm just going to write in average. I would like to calculate the average, so I'm going to click on that, and it's going to put in a parenthesis for me. All I have to do is highlight the data that I want to average. I just want to average the caffeine measurements together. So I'm going to go ahead and hit that and enter, and it'll average that out for me. In this one, I'm going to do the same thing, equals average, okay, and then I just need to highlight and hit enter. It averaged it all out for me. So in this one, my average was 156 beats per minute, and in this one, my decaf average was 131.2. Now, I talked previously about t-tests, and you've already seen a video on what a t-test is. I'm going to show you how to run a t-test on my data and to tell you how I would describe my data so that you can use a model or use this as a model for how you describe your data in your analysis and conclusion. So, I'm going to do pretty much the same thing. I'm going to hit the equals button, and in capital letters, I'm just going to write out t-test. Okay? Now the t-test is going to be done between this group of data, okay, and so I'm going to put a little comma there. It's going to be done between this group of data. Now, this particular t-test, I have a couple of different ways I could have asked my question. If I said, will caffeine increase the rate of respiration or the heartbeat per minute of the Daphnia, then I would have a one-tailed t-test. But if I just said, will there be a difference in the experimental group and the non-experimental group in the heartbeat per minute, then I can use a two-tailed test because I really just don't know. Is it going to be less? Is it going to be more? I don't know how the Daphnia are going to react. So I'm going to put a 2 to say that it can be either side of the spectrum. Okay? And then the next thing that I have to figure out is this a type 1, a type 2, or a type 3 t-test. So the type 1 is where you have the same patient in both the first group and the second group. In a type 2, you have the same number of variables, so you have 5 sets of data for each group, but and so you have equal number of variables for each group. Okay? And then the third type of variable is when you got, let's say you did 5 trials for caffeine, but in your decaf group, while you were testing, you did 3 trials and then 2 of your Daphnia died. Oh man, what are you going to do then? Well, you just record the data you have, but that would be a type 3 t-test. Okay? So in this case, I am not connected between this organism is not connected to this measurement. So I am not going to use a type 1, but I do have equal numbers of each type of data. So I'm going to use a type 2 t-test. All right. So I'm going to calculate my value. Oh, look at that. So my value is 0.006, right? So roughly speaking, if I was to multiply this by 100, I would end up with a 0.6% chance that my difference between my experimental group and control group is due to random chance. That's a very, very small chance that there is not something funky going on here. So if you guys remember, we had our hypothesis, which was that if caffeine is added to the Daphnia habitat, then the heartbeat of the Daphnia will, and you might have said increase or decrease, and you might have just said change. But your null hypothesis said there's going to be no difference between, or no significant difference between the experimental group and the control group. In this case, there's only a 6% chance that this big of a difference between these two groups is just due to random chance. So I can reject my null hypothesis. I can say that I can say no. There is a significant difference between my two groups. Now, whether or not that significant difference is due to the caffeine or not, I can't prove as a scientist. But I can say that my hypothesis was supported by the experiment. And as a scientist, I know that means I need to revise and re-experiment. So, let's go ahead and do this for the different type of test that you did. So let's say that we are doing primary productivity. And you, that's not what I wanted. You tested your control group in your BOD model and your experimental group. So let's say this is your experimental group and this is your control group. And this was the change in dissolved oxygen was I don't know, let's say 23, 22, 24, 25, and we'll do something random like 13, because we always have one of those random values in there, right? And this will be parts per million. Okay, dissolved oxygen. And
in your control group, your change in dissolved oxygen, let's say was 21, 22, 19, 22, 20. Okay. So once again, we're going to calculate the average. And I'm going to put the equals button. I'm just going to write out average. And this should pop up. If this doesn't pop up, you can just put the parentheses in yourself and then highlight the data. And over here, our averages. Okay. So now we're going to run a t-test on this. So I'm going to do my t-test. And I'm going to hit the equals button, and I'm going to write t-test. Okay. And my t-test is going to be between this set of data, comma, and this set of data, comma. I'm going to say I don't know which direction it's going to go, so it's a type 2. And this group was not connected to this group. This was not the same sample or the same time or anything like that. It just happened to be that these were randomly taken samples and these were randomly taken. Okay? And so because of that, that once again is a type 2. So I'm going to go ahead and hit enter. Now, you can see that this value is not below 0.05. In fact, it's 0.79, which means there's a 79% chance that the difference between this data and this data is just due to random chance. I could almost say an 80% chance. Okay? So in this case, I cannot reject my null hypothesis. And my null hypothesis said there was no change between the control and the experimental group. So I have to accept that. There was no change. There was no statistically significant change. Once again, I do not reject my null hypothesis, which stated there was no change between the experimental group and the control group. There's no statistically supported difference between the experimental and the control group. So I cannot reject my null hypothesis, which means that my hypothesis that my experimental variable was going to make a change was not supported.
I hope that this was helpful in helping you determine how to run a t-test using Google Sheets. Please feel free to contact me via email or see me tomorrow with any questions that you may have. And good luck studying on your quiz. For the rest of the class, I would like you to please do the review worksheet on vocabulary, and I would like you to finish working in your groups on your analysis and conclusion. Those will be due printed to me on the day of your exam, which will be on the 15th. Good luck, good studying, and I'll see you tomorrow. Thanks.